Hello, today we are going to look at a problem in financial maths. It involves calculating the repayments on a loan by using geometric series rather than the amortization formula. Here's the problem. Susan borrows €20,000 to buy a new car. She agrees to repay the loan and interest by a series of monthly repayments starting 1 month after the loan is issued and continuing for 5 years, in other words 60 repayments. If her bank charges an APR, annual percentage rate, of 9.3%, calculate the equivalent monthly rate of interest. Give your answer as a decimal, correct to 6 significant figures. Then, using geometric series, calculate, correct to the nearest cent, the amount of our monthly repayments. First of all, we need to tackle part 1, where we calculate the monthly rate equivalent to an annual rate of 9.3%. The reason we need the monthly rate is because it will be used in the calculation in part 2. Let I be the monthly rate equivalent to an annual rate of or is equal to 0.093, which is the annual rate written as a decimal. The link between I and or is 1 plus I to the power of 12 is equal to 1 plus or. This is because accumulating for 12 monthly periods is equivalent to accumulating for 1 year period. Now, replacing or with 0.093, we then put each side of the equation to the power of 1 over 12 to get 1 plus I. This can all be done on a calculator. Now, by calculator we get 1 plus I to be 1.007438043. By subtracting 1, we get the value of I to be 0.007438043, which is 0.0074380.4, correct to 6 significant figures. For part 2, we need to set things up carefully. First of all, we will agree to take the present to be the date the loan is actually handed over to Susan. This can also be called the evaluation date. To form an equation called the equation of value, it is necessary to find the present value of the loan and all repayments on the date taken as the present. The present value, which we'll call PV, of the loan is its stated value, in other words, €20,000. Now the present value of each of Susan's repayments needs to be calculated. Let the actual value of each of her repayments be €1. First we consider her first repayment, which will be made 1 month after she gets her loan. Because this payment is to be made after the present, it needs to be discounted by 1 month, which is 1 time period, to find its present value. This is A divided by 1 plus I, where I is the monthly rate of interest found in part 1. We will leave it as I for the moment. In the same way, the present value of the third repayment is A divided by 1 plus I to be cubed. Carrying on to the end, the present value of the last repayment, due 60 months after the loan is given, is A divided by 1 plus I to the power of 60. The present value of all Susan's repayments can be found by adding together the present values of all her individual repayments. This is a geometric series. We need to find its sum in terms of A. To make this easier, we can use a technique designed to simplify the calculation. This comes from actuarial work. We let the letter V stand for 1 divided by 1 plus I. Now each of the terms of the series can be written in terms of A and V. First of all, A divided by 1 plus I can be written as AV. All the terms of the series can be treated in the same way. For example, the second term, A divided by 1 plus I to be squared, can be written as AV squared. The last term of the series can then be written as AV to the power of 60. Now we can rewrite the expression for the present value of all of Susan's repayments in terms of A and V. This is a geometric series with first term, small a, equal to capital A by V, and a common ratio or equal to V, and with 60 terms, in other words, n is equal to 60. The formula for the sum of n terms of a geometric series is given on page 22 of the formulation tables. This is Sn equals a times 1 minus or to the power of n, all divided by 1 minus or. Using this formula to find the sum of the present values of all Susan's repayments, we get A by V by, in brackets, 1 minus V to the power of 60, all divided by 1 minus V. This can also be rewritten by taking A out in front. Now we focus on using a calculator to calculate the expression in the brackets. First of all, we calculate 1 over 1 plus I. In other words, 1 divided by 1.00743,804. This is V. Now the value of V is stored in the answer memory in your calculator. We can now calculate the value of the bracket using the answer memory on the calculator. Press fraction, answer, bracket, 1 minus answer to the power of 60. Close the bracket, then scroll to the bottom line and press 1 minus answer. From the calculator, the value is now 48.25721841. By the way, this is now the value in the answer memory. Thus, the present value of all of Susan's repayments can be written as A multiplied by this number. Now we can form an equation that will allow us to calculate A. This equation is the equation of value, which says that the present value of the payments made by one party must be equal to the present value of the payments made by the other party to the loan agreement. The equation of value now states that A times 48.25721841 is equal to 20,000, the present value of the loan. To find A, we divide across by 48.25721841. In practice, as the value 48.25721841 is stored in the answer memory, we can calculate A by dividing 20,000 by answer. On the calculator, the answer is 414.4457691. To the nearest cent, her monthly repayment is €414.45.